This is problem number 17 from the 2006 AMC8. And it's an interesting problem where you've got to find a probability of adding a sum. And we want to know just when that sum is an odd number. If you look at this, each of these regions are going to have a probability of 1/3. Each of these are going to have a probability of 1/4. And each of these regions are going to have a probability of 1/6 because that's how many numbers are in each of those. Now, the important fact you need to understand about getting a sum of an odd number is you either need to have exactly one odd number or all three of them being odd numbers. Because if you have two odd numbers, an odd plus an odd is an even, right? 3 plus 5 is 8, 7 plus 13 is 20. Any two odds you add together always give you an even number. And then if you add an even with an even, it always gives you an even. So the only way to get an odd is to get either one odd or all three of them to be odd. Well, you can't get all three of them to be odd because if you take a spinner in spinner Q, you always end up with an even number. So the only one way to get one odd is either for P to be odd or R to be odd, but R is always odd. So that means that P has to be 2. So it turns out that because this is always an even and this is always an odd, that this problem comes down to when can P be an even number, and P is an even number exactly 1/3 of the time. So the answer to this question is 1/3 of the time when you add up the three results from the spinner, you are going to get an odd number. There's a lot of ways you could have gone about trying to do this problem. You could have listed out all the possibilities. There's not a ton of possibilities. There's 3 times 4 times 6, and so you could have gotten a pretty good idea and a good pattern way to do it and come up with an answer. But the best way to do it was to realize that these two always produce the same thing, an even and an odd. And so the fact of it being even or odd came down to P at all times.